Hello, welcome back to the channel. Welcome back to another Will It Work episode. And the product this time is a Lisle test light, the 28800 digital test light with load tester. So obviously, to start with, we'll read the little blurb on the back. So it's a 3 to 30 volt DC dual polarity digital test light that also checks voltage drop on circuits instantly. Works as a regular test light, and when you push the button on the side of the tool, it applies an 800 milliamp load at 12 volts DC to easily check for voltage drop of circuits. The display will indicate the voltage drop when the button is pushed. Displays voltage under load to tell if the circuit has problems like corrosion, resistance or faulty connections. It's not computer safe with the load applied. It's not for use on airbags, and the bulb will automatically turn off after 5 seconds, so you will need to push the button again to reapply the load. So yeah, let's get into it. This is actually the second one of these that I have owned. I ruined my first one. Was it last week or the week before? Trying to get all scanner dana with it and use it to check for spark coming out of ignition coil. So I would not recommend it for that. Oh my god. But it has been probably the best test light that I've owned. Before this one, I had a couple of snap-on ones. I had the snap-on LED test light with the digital display, like what this has. I also had the snap-on just normal incandescent test light, and I found I was using them together. So I would obviously read the voltage with this one and then tap the incandescent one on the end of this, see if the voltage was to drop. But this is just handy and provides it all in one unit. Oh, the little protection thing for the sharp point stuck in the packaging. Do I want it? Oh, come on. Oh, not yet. No, I don't. Right. So price. Did I pay £70 for this? It was off Amazon. I had to get it from America. Didn't take too long to turn up, to be fair. Amazon's pretty good. And yeah, if you think it's expensive compared to some test lights, it probably is. However, the snap-on one I bought, LED one, was about 80 quid plus the VAT. And then I had to add the normal incandescent one, which was maybe 30 or 40 plus the VAT. I've since sold both of them on eBay, and I think I got at least 100 quid for the pair of them. So technically I've been paid £20 to now have this test light, if you want to break it down, although I've had to buy it twice, so I'm still out of pocket. Either way, yeah. Right, so first thing, I think we'll just hook it up to a battery and show you the dual polarity of it. So let's go. So I'm clamped here on battery negative, so we know what's going to happen. If I touch positive here, we get 14 volts. I'm going to press the button, and that's a drop of about half a volt, 0.4 of a volt. I want you to take note of that when it comes to load testing components like these fuses. I'll do one now actually, look. Now I think a lot of us are taught that half a volt, the voltage drop, is bad. It means there's resistance in the circuit. But obviously, as we have seen, when we go straight across the battery, we get the same drop anyway. So in this instance, that's not an issue, and this really is just about knowing your tool. If you know that this is going to drop half a volt when you push that load, you're going to be looking for something more than half a volt when it comes to checking for, you know, things like high resistance or corrosion. And we'll just go clamp on positive. Now we're on the negative, so we go here. Now just on engine. So there we are, straight across the battery. Let's check some fuses now, shall we? I've just shown you a few, but there's a couple of little ones in here. Press the button, 13.8. Come across the other side, press the button, 13.8. Now obviously, this is going to be putting slightly more than an 800 milliamp load across these fuses, because I've got the engine running. We've got nearly 14.5 volts, so we could be 900 milliamp, could be just shy of an amp. But this is a 20 amp fuse. This one is, that's a 15 amp fuse. It isn't going to do any damage whatsoever. Test the power coming straight in as well, look. Right, let's look at some fuses that I've planted. One. It's obviously faulty, blown. This one isn't. And this one has got something weird going on. If you press the button, the LED goes out. Can't carry the current, and that's because I've made it so. That fuse wire is barely, I've actually ripped that fuse wire and just sort of pushed it back into contact with the blade of the fuse. So there we are, some fuses that are not okay. So what else would I use this for? Well, for me, I like testing glow plugs with this. Obviously, glow plugs are permanently connected to earth. They're screwed into the cylinder head of the vehicle, which obviously is grounded. So if I attach this onto the positive side and then try and find a path to earth with this tip through the glow plug, I can read the voltage that is allowed to pass. Press the button, I can see any voltage drop through the glow plug. So I'll show you that. I've got a selection of glow plugs in an unknown, in an indeterminate state. I don't know what's good, what isn't. Using it as a substitute for components, probably is its downfall. You probably can't do this as easily as with a normal incandescent test light, because you've got to hold the button to get, obviously, to activate the load. So that's probably a no-go. What I used it for not long ago was on a Vauxhall Astra. I had a boost control solenoid fault. When I power probed the solenoid worked. The turbo, obviously you can see the turbo actuator moving up and down, but the resistance of that solenoid was too low, and the ECU knew that. I think too much current was flowing, so it just shut the circuit down completely. So even if you were to volt drop that circuit with a multimeter, because that component isn't being activated, you wouldn't get a true volt drop reading, because current has to be flowing for volt drop to occur. So now that circuit had a permanent power supply from a 10 amp fuse. So obviously I hooked this up to negative, probed the harness on the positive side with this, pressed the button, checked for voltage drop. There wasn't any. And the earth side was computer controlled, so I didn't use this to check the earth side for obvious reasons. It's not computer safe. What I did instead was disconnect the wire at both sides, so boost control solenoid side, ECU side, use this and an extra sort of just banana lead with crocodile clips on to load test that wire. The wiring passed okay. Obviously the fault was the boost control solenoid. Right, so here's the test. This is my negative lead, which I'm going to connect to the body of the glow plug as if it's been earthed through the cylinder head. A test light is connected to battery positive, so I can just take it, drop it, and it can go into the top of here. Obviously with LED, it's obviously reads as fine. Press the load button and we can see that is not a healthy glow plug. The bulb is barely lit if you look at that. So that is bad. Let's move on to the next one. Same again. With LED lit, it's obviously fine. Press the load and this one is even worse than the last one. Next. Again with LED, this one's fine. Press the load, and this one is actually a healthy glow plug by the looks of it. Another one. Well, this one is knackered. Press the button and the LED just flickers. Next. This one appears to be healthy. Next. This one also appears to be healthy. This one isn't. As soon as you press the button, the LED just flickers. This one appears to be healthy as well. Do you get the picture? There's only 2 left, we might as well. This one seems to be healthy. Last one. And this one appears healthy. Okay, so what if we had resistance in a wire? Now I've got this, it says Math Simulator on it. What it is just a variable resistor inside a box. So I'll just show you right now. Okay, so with this turned all the way to max, I get about 3 ohms of resistance. That's the black lead clipped onto there, red probe on there, if I can hold it still. 3 ohms. So I'm going to turn this until the test light shows a volt drop on here. So I've got the negative hooked up to one side, to the negative of the battery. Our test light is hooked up to the other side of this, and we're going to go to battery positive. And obviously we get what we'd expect. How can I do this? I need more hands. So obviously this was without pressing the load. I'm going to turn this, see how much drop we get. Oh, we're starting to drop now. Round about there. So I'll measure the resistance on that. I might need to switch it to 2 kilo ohms. So this LED will detect the voltage drop at about 200 ohms. What happens if we press? Oh, and look at that, if we load the circuit there, did you see that? We're still at the 200 ohms, but we get a big drop there, down to 9 volts. How much resistance will we need? I haven't got enough hands, so I'm going to turn this back slightly, pop this on. So the LED hasn't detected the resistance yet. If we load it, you can see we're dropping about 3 volts there. What if I turn this back a bit more? Now we're dropping about 2 volts. Still too much. Watch the resistance of this now. Look at that, it's 10 ohms. With 10 ohms of resistance, we can detect a 2 volt drop. Let's turn this back a little more. For about 7 ohms of resistance. What sort of voltage drop will we get? Yeah, still about 2 volts. 14.3. Load it. 12.5. And that's with 7 ohms of resistance. I'll try and prop this camera up, I think. Can we prop it up anyway? So if I load it, oh my god, I'll try and go back a bit more. At what point does the voltage start to drop? To be fair, I don't think it really likes the 3 ohms that's in there. So there we are then, that is the Lisle 28800 digital, what is it? Digital test light with inbuilt load tester. Will it work? Yes, it will. Quite well, to be honest. Now I know it's just another tool, isn't it? I mean, volt drop can be done with a multimeter. Load Pro leads can be bought, used with your multimeter. That is a similar thing to this. It's going to be whichever tool you feel most comfortable using. I've owned a set of Load Pros. I found that I didn't really use them. I found a multimeter I don't really use. If ever I have an electrical issue, the first thing I grab is an oscilloscope. Nothing fancy, just a little 2-channel handheld built into, well, at work it is into a Hella scan tool. The one at home I've got is built into the Snap-on Modus Ultra scan tool. The reason for that is because I was doing a washer pump, or trying to trace a washer pump fault. I think it was on a 2016 Volkswagen Crafter. The washer pump didn't work, so I was trying to volt drop, you know, negative to negative, positive to positive. The washer is only a 2-wire pump, isn't it? It needs power and a ground to work. But what the multimeter didn't show me, I was using multimeters at the time, was it was a pulse width modulated signal. So when I was volt dropping it, the readings were not as I was expecting. The multimeter was was it flashing a bit? It was doing something funky. So I thought, get the oscilloscope, and yeah, I saw, you know, the pulse width modulated square wave signal. Since that day, I have used oscilloscopes religiously because I don't want to waste time. I don't want to get caught out on something that should be as simple like a washer pump. So yeah, multimeters don't really use anymore. So the Load Pros, I sold them. I think I paid about £70 for the Load Pros. So, you know, this instead, it's whatever is, you know, whatever you find most comfortable working with, whatever's going to make you get to the root of the problem really quicker. So that's the Load. That's not the Load Pro, is it? Oof, that is the Lisle 28800 test light. I didn't show any 5-volt stuff. I had it on my notes to show some 5-volt things, but because this isn't computer safe, I don't want it to come across as if, you know, you can just press this button on a 5-volt supply and everything will be okay, because it may not be. Anyway, that's that. End of video. This works. I love it. I might buy another one for home use. This one I'm going to take to work. So yeah, that's that. Cheers for watching. See you next time. Bye.